In a previous chapter in your book, we talked about something called desk checking. This video is going to teach you how to trace a program. Tracing a program is a form of desk checking, where you're checking the logic of your program without actually executing it on a computer. You can trace your program from either a flowchart, pseudocode, or from actual programming code, for example, basic code, which we'll be doing in the future. Here we have a flowchart that we're going to use to learn how to trace. So the first thing we do when we're tracing a program is we look at all the variable declarations, and then we make a place where we can take note of the current value of the variable. So in this case, we have a variable number. And then the other thing that we may need to keep track of is the actual output the program generates to make sure it's what we want. So I'm going to allocate some space to print output. And then we go to the start of our program and we start tracing. So here we're going to input a value from the user and store it in the variable number. As we talked about previously, we shouldn't make any assumption in the beginning as to what value is currently a number. We can just consider it garbage at this point. But when the user types a number, let's say for example they type in the number 4, then the variable number gets set to 4. So we make note of that. We then go into this decision block that's asking the question, is the current value of number less than 10? Well, 4 is less than 10, so we take the yes branch and we go down to this box. And what this is saying is get the current value of number, add 1 to it, and store it back in number. So the current value of number is 4. We add 1 to it. That gives us 5. We store it in the variable number. The next block, as we trace through this program, has an output statement. It's going to output number is and the current value of number. So it'll output number is 5. We go back to the point right before our decision point. We now ask the question, is 5 less than 10? The answer is yes. So we go through this block again. Number gets 1 added to it. It is now 6. The output statement prints number is 6. And then we go back to the top of what ultimately is a loop. The current value of number is 6. 6 is less than 10, so we go out the yes branch. We set number equal to number plus 1, so it now has the value 7. We output number is the current value 7. We go back to the top of our loop. 7 is less than 10, so once again we go out this branch. 7 plus 1 is 8. We store that back into the variable number. We output number is 8. Go back up to our decision point. 8 is less than 10, so once again we go out the yes. We set number to number plus 1. We output number is the current value, which is 9. We go back to the top of the loop. 9 is less than 10, so 9 plus 1 is 10. Store that number. We do our output statement again, which says number is 10. We go back to the top of the loop. Now we ask the question, is 10 less than 10? That is false. So we take the no answer. We have a block here that outputs number is the current value of number, which is still 10, and then our program terminates. Now, if this is the output we expected or the behavior we expected from our program, then we know it works correctly. If there was something that didn't work the way we intended, for example, let's say, I wanted to go 5, 6, 7, 8, 9, 10, and this is extraneous to say number is 10 again, then we could go back and say, oh, I really need to delete this step or change it to something else. So that is an example of tracing through a program to make sure it functions as you intended.